Greetings. My name is Richard Taylor, and in this video I'm going to try to explain something that we've seen our entire lives and probably never gave it much thought. It's called the moon tilt and rotation illusion. This all started when I was having a discussion with a guy that believes the Earth is flat. And he was explaining how the shadow on the moon cannot be caused by the sun because sometimes the shadow does not point directly at the sun. He was also saying that the moon and its shadow rotate as the moon travels across the sky, and that it even rotates backwards sometimes. We've been taught all of our lives that the moon is lit by the sun and does not rotate, right? I thought to myself this should be easy to explain, but it was not. I also found that most people couldn't explain this in detail either. So I decided to make this video in the hopes of educating a few folks. Since this is my first video, and I've heard that most people will only watch a video for a few minutes, I'm going to go straight to the answers. If you don't understand something or just interested in learning more about it, keep watching and I'll cover it all in painful detail later in this video. So back to me thinking this would be easy to explain. I stepped outside at work one day and I took this picture of the moon and the sun. Then I drew a line between the moon and the sun and sent it to the guy, showing him that the sun is perpendicular to the shadow on the moon. He said that he has seen it not line up. So about a week later, I went back out and I took this picture. The sun was directly behind me, but the shadow pointed to a light source that should be very high and off to the right. I thought, that's interesting. I've been looking at the moon all my life and did not notice that the sun would sometimes not line up with the shadow. After doing a little bit of research, I found that this is an optical illusion that we see everywhere, every day. I saw some different stuff on the internet that I figured would help explain this. If you hold a ball up between your eye and the moon, the shadows will always match on the ball and the moon, if the sun is up, of course. So I took it a step further and put the ball on a pole and put my welding helmet lens on another pole, then put my camera tripod in between them where I could see the moon in line with the ball and then spin the camera around and see the sun through the welding lens. Then I ran a string between the two, and sure enough, the string is perpendicular to the shadow on the moon. Here's a video of it. It still messes with my head every time I watch it. The effect is called perspective projection, and again, I'll get into the details later, but the bottom line is if you cannot fit both the sun and the moon in one camera frame, the shadow will not appear to line up with the sun. A panoramic picture has a similar effect, as you can see here. All right, explaining the rotation of the moon shadow is a little harder to visualize. So we've got a little setup here. We've got our moon over there. That flashlight's simulating our sun to give us a shadow on the side of the moon. We have our little expendable Star Wars pilot here. And when he's standing right here on the Earth and he looks at the moon shadow, if he were to hold his camera out and take a picture of it, the shadow on the moon is going to be straight up and down in that picture. If he were to stand down here on the equator and take a picture of it, he would be holding his camera like this. The shadow on the moon would appear to be horizontal in that picture. It all has to do with his perspective. To him, level is horizontal with the ground. It's based on gravity. Wherever he is on the Earth, level is relative to the surface of the Earth at that point. So if he's looking at an object that is not moving, for instance, down in the southern hemisphere, if he were to take a picture of the moon, it's going to appear upside down from taking a picture up here in the northern hemisphere. Keep in mind, if he were standing over here, he's still going to hold his camera level, but it's going to be tilted up. Same thing if we're taking a picture here on Earth. If I look up to take a picture and tilt my camera up, I'm still holding it level based on gravity. I've got some apps on my phone that tell me when my camera is level or not. The rotation of the shadow comes in with the rotation of the Earth. Well, let's use Atlanta. So he's standing here in Atlanta. When he's back over here, now he would be able to see it because he's about 1,000 miles tall. But if you were on the surface of the Earth in Atlanta, right about here, the moon would be rising over the horizon. And if he were to take a picture of it, he would be looking like that. Now, a couple hours later, when the Earth is rotated like this, he now has turned and is looking up. So he's holding his camera like this. It's getting slightly angled. Now he comes over here. Now he's turned and now he's holding his camera like this. So each time, even though the moon has not moved, he has rotated his camera around every time he took a picture. And that shadow is going to appear to rotate in each picture. So I set up a test to try to explain this. I made a little device here, a little stand here that I can clamp my phone camera in. Actually, it measures the angle of the camera and also measures it's called the azimuth as the camera rotates. And so here's north. So what this stand does is no matter where you are on the Earth, the phone will always be level to the surface of the Earth at that point. So if I can figure out where the Earth is relative to the moon and what time of day it is based on where you are on the Earth at that point, then I can put my phone there and I can take a picture of the moon, and I should get a picture that matches a picture taken on Earth at that location on that date at that time. All right, so what I did is I took an exercise ball and marked it with longitude and latitude lines and figured out where its axis of rotation should be on March 14th, 2019, based on the moon being right here and the sun being over there. And I've picked the town of Coos Bay, Oregon as my observation point. And based on its longitude, this line would be midnight. So if I go to this point right here, this is where I would be in space on March 14th at midnight. And if I take my camera stand and I position it right here, put my camera in, point the camera, and take a picture, that's what the moon tilt should look like, again, at midnight on March 14th in Coos Bay, Oregon. So what I will do is I will go all the way around. There's 1 o'clock, 2 o'clock, 3 o'clock, and so forth for 24 hours, take 24 pictures, and then we can compare those with what the moon should actually look like. First of all, what are we talking about when we say moon, shadow, tilt, and rotation? Here's a picture of a cue ball representing the moon being illuminated by flashlight, which is representing the sun. The vertical line between the shadow and the lit part is called the terminator, and it should always be perpendicular or 90 degrees to the source of light. There are two different ways to make the terminator tilt and rotate. The first is to move our light source. See, as we move the light down and up, the terminator appears to rotate. If we bring the light source towards the camera, we see the shadow disappear. And if we take the light source away from the camera, we see the lit part disappear. The other way to make the terminator appear to tilt and rotate is to change our viewing angle. If I rotate the camera, I see the terminator appear to tilt and rotate. This is what's happening on the Earth. As the Earth rotates, our viewing angle changes. We don't realize it because we are always level to the Earth. Also note that if I bring the camera around to the back side, we see that same moon phase effect. This is caused by the moon orbiting the Earth. And I'm going to show another example of that here in a minute.
Before we move on to the good stuff, we need to do a quick review on how the Earth and Moon orbit the Sun. If this light bulb represents the Sun, and we're looking down from the north on the Earth, we would see that the Earth rotates counterclockwise, roughly 24 hours per rotation, and the axis that it rotates on is actually tilted. It's tilted about 23.5 degrees relative to the orbit of the Earth around the Sun. This axis points almost directly at the star Polaris, and the Earth orbits the Sun counterclockwise, and this axis of rotation of the Earth never changes. It always points at Polaris. This is actually what gives us our seasons. Now, the Earth's orbit is not a perfect circle. It's actually slightly elliptical, but that doesn't affect our seasons as much as the angle that the sun light hits the Earth and how long our days are. Right now, the northern hemisphere would be in spring. Right here, the northern hemisphere would be in summer. Our days are really long, and the sun's rays are hitting more directly on the surface of the Earth. It's heating it up more. Over here, we would be in fall, and over here, the northern hemisphere would be in winter. The days are very short, and the sun's rays are hitting at more of a steeper angle. At the same time, the southern hemisphere would be experiencing summer right now. As we come around back to spring, let's talk about the moon. So the moon orbits a little less than 28 days to complete one orbit around the Earth. Its plane of orbit is about the same as the plane of orbit of the Earth around the Sun, but it's tilted a little bit. And this is why we sometimes have eclipses. So first of all, if we're standing here on Earth and looking at the moon, this would be the first quarter. The illuminated side is on the right, and the shadow side is on the left. Over here, we would have a full moon. Now, if the Earth and the Sun were directly in line with the moon, we would have a lunar eclipse. Over here, we're in the third quarter, or last quarter, and if we're standing here on the Earth looking at the moon, the illuminated side is on the left, and the shadow side is on the right. Over here, the illuminated side was on the right, shadow side on the left. And then coming back around, now we're at a new moon. This is only out during the daytime, and we can't see it. There's actually no illuminated side for us to see. All we see is the shadow side. One other little neat misconception with the moon is the dark side. Everybody always talks about the dark side of the moon. I'm going to put a piece of tape on the moon here just to represent. The moon actually makes one rotation per orbit because the same side of the moon always faces the Earth. So if you're looking down on it, you would see the moon complete one rotation. When people say the dark side of the moon, they're actually referring to the side that we can't see. We never get to see that back side of the moon, but it's obviously not the dark side of the moon. When it's right here, the side of the moon we can't see is actually completely illuminated. Over here, it's half illuminated. So pretty neat.